The piano. 88 black and white keys. From a low A to a high C. It is an intuitive, easy-to-use instrument. Press the keys and a sound emanates from the piano. But how exactly does a piano work? On the outside of a piano, you can see the keys and the pedals. However, there are several basic parts inside of a piano. The strings, the hammers, and the dampers. When you press a key, the damper lifts off the string and the hammer hits the string. When you release a key, the damper presses down on the string again, stopping the vibrations. You can see the strings are different thicknesses and materials and length. How does this affect the noise of the piano? The thicker the string, the lower the frequency and the lower the pitch. A thinner string means a higher frequency and a higher pitch. Now, these are the basics of a piano. However, there are still the pedals. The leftmost pedal creates a quieter noise. On a grand piano, it shifts everything, meaning that only 2 of the 3 strings are hit. However, on an upright piano, like the one that I have, it just moves the hammers closer to the strings. The rightmost pedal makes the noise of the piano continue. It lets the vibrations continue instead of stopping them with the damper. This pedal raises the dampers up even when a note isn't being played. That is how a piano works. The sounds then travel through the air and into our ears. But wait, how do our ears hear sound? Sound travels into the ear through the ear canal. It causes the eardrum to vibrate. The vibrating eardrum makes 3 small bones in the ear vibrate too: the malleus, incus, and stapes. While the sound wave travels through the bones, it gets louder. In the cochlea, which is filled with liquid, there is the basilar membrane. When the stapes, the small bone touching the cochlea, pushes on the membrane covering a hole in the cochlea, and also known as the oval window, it causes a wave to go through the cochlea. This makes the basilar membrane move up and down. The hairs on the basilar membrane sense this. They make the stereocilia, structure similar to hair, bend. An electric signal is made and sent to the brain via the auditory nerve because of this. That is how a piano works and how the ear hears sound.